Well, this is just a quick refresher about finding the asymptotes of rational functions. Nothing new, you knew it. I just thought, I just briefly talk about finding asymptotes of rational functions. Okay, so there's one example right there, y equals negative 2x over x plus 4. We want to find the vertical asymptote. You have to set the denominator equal to 0 to find that. So by setting the denominator equal to 0, I get x equals negative 4. That's the equation of the vertical asymptote. For the horizontal asymptote, because the degree of the top and the bottom are the same, so I'm going to just take the ratio of the leading coefficients. That's negative 2 over 1. So the answer is y equals negative 2. That's the equation of the horizontal asymptote for this rational function. Slant asymptote, we don't have any because slant asymptotes happen only when the degree of the top is one more than the degree of the bottom. And in this case, both top and bottom are linear functions. Obviously, we don't have any slant asymptote. Next exercise, we see that the denominator again is x minus 5. So by setting it equal to 0 quickly, you can find the equation of the vertical asymptote, x equals 5. Horizontal asymptote, well, we don't have one because the degree of the top is more than the degree of the bottom. So if the degree of the numerator in a rational function is more than the degree of the denominator, like the case is here, we don't have any horizontal asymptote. So I put no horizontal asymptote. Instead, because the degree of the top is one more than the degree of the bottom, then we do have slant asymptote. And in order to find it, if you recall in the advanced functions course, we said that we have to use this so-called long division method. I'm dividing top by bottom, so I get x times x is x squared minus 5x. I subtract them, and I get 5x. Continuing the long division process, 5x divided by x is just 5. Multiply back, minus 25, subtract them. I get a remainder of 25. So we said that this quotient you see is actually the equation of the slant asymptote. So y equals x plus 5 is the equation of slant asymptote for this function. So in the past exercise, we had one vertical, one horizontal, no slant asymptote, one vertical asymptote, one horizontal, and no slant asymptote. In this one, we have one vertical, no horizontal asymptote, and one slant asymptote. And we did find all the equations. For this next one, if you factor the numerator, it would be x minus 1 times x plus 1 over x times x plus 1. So you might notice that the factor of x plus 1 is a common factor in the numerator and denominator. So in this past exercise, for example, when x was approaching 5, y was approaching infinity, meaning that x equals 5 was the vertical asymptote, because the numerator would approach at 25, but the bottom would approach 0. Even in this case, when x approaches negative 4, the numerator approaches 8, the denominator approaches 0. So we have a number, non-zero number, divided by 0, approaching infinity. But that's not the case here when x is negative 1, because if x is negative 1, we have 0 over 0. So it's not like the function is going to approach infinity, just like in the past cases. So as you might recall, this situation is where we say that there is a hole at x equals negative 1. So I'm going to say a hole at x equals negative 1, but I'm not going to say it's a vertical asymptote. And then instead, if x is 0, by setting the denominator equal to 0, of course, that will be the equation of the vertical asymptote. Moral of the story is this: just blindly, without thinking, without checking the factors of the numerator, you should not just say, any root of the denominator is going to be the equation of the vertical asymptote blindly. No. If I would do it that way, I would say, okay, x equals negative 1 is a vertical asymptote, and I would be making a big mistake. So always check to see if the root of the denominator and the numerator are the same or not. If they have common factors like x plus 1 in this case, then you might be looking at a hole in the graph rather than a vertical asymptote. So unlike what you thought initially, we don't have two vertical asymptotes. There's only one vertical asymptote. For the horizontal asymptote, the degree of the top and bottom are both like 2. They're both quadratic. So the ratio of the leading coefficients is 1. So y equals 1 is the horizontal asymptote. And slant asymptote, of course, we have no slant asymptote because, as you know, whenever you have horizontal, you don't have slant. Whenever you have slant, you don't have horizontal asymptotes. They're not like friends. They don't go together. The last one, the degree at the top is way big, right? So it's not one more than degree at the bottom. So it's two more than in this case, sometimes even more. So that means that we don't have slant asymptote. And also we don't have horizontal asymptote either. The only thing we have over there is just x plus 2, which you set it equal to 0, you get x equals -2, the vertical asymptote. But in order to make the question more exciting, I'm going to change these exponents if you don't mind. I'm going to change that 3 to 5, okay, and then this bottom I'm going to put x squared. So the bottom, I change it to x squared plus 2. The top is x to the 5 plus 5x minus 1. So again, same issue. No horizontal, no slant asymptotes. But about the vertical asymptote, you may notice that x squared plus 2 is an always positive expression, which is never ever equal to 0. Even if you try to set it equal to 0 to find the roots, you will not be able to do that. The equation has no solution. The quadratic equation will not have any roots. Therefore, the conclusion is that even that function, it does not have any vertical asymptote. So this was a very interesting exercise. I made it up by changing the exponents, that despite the fact that it is a rational function, but look at it, we have absolutely no asymptote of any kind whatsoever. No vertical asymptote because the denominator is always positive, it's never 0. No horizontal asymptote because the degree of the top is more than the degree of the bottom, and no slant asymptote because the degree of the top is way bigger than the degree of the bottom. All right. So perhaps this was a quick refresher about how to find the asymptotes of rational functions. Okay. Maybe I can quickly summarize. Here we had one vertical, one horizontal, 0 slant asymptote. Here we had one vertical, 0 horizontal, 1 slant asymptote. Here we had one vertical asymptote, x equals 0, 1 horizontal, and 0 slant asymptote. And here we had actually nothing, no asymptotes at all. So it's kind of interesting when you want to consider the number of asymptotes in general that a rational function can possibly have. Thank you very much.